So everyone is going to need a calculator, so make sure you have your calculator out so you can get to it. Okay, so this first part, listen. If you'll remember back to when you were in Algebra 2, for some of you that was a little while ago, some of you it was a little more recent, but it's probably still been a little time. Back when you were in Algebra 2, you did a lot of work with parent functions and doing transformations with those, right? You did a lot of vertical stretching, horizontal movements, vertical movements, all these different things. So now we're going to look at how those types of things affect our summary statistics. So when we do that one variable stats, how are the things that are given to us there affected by adding a value or multiplying by a value or squaring numbers or all these things? How does it affect them? Okay, so that's what we're going to be looking at, is that idea from Algebra 2 moved into what happens with data when these things happen. Okay, so this first one is our original data set. So here, you'll notice you're given a set of data. So you're given this set of data. Let's put this into our calculator in L1. So to get to that, we're going to do stat, edit. And if you have numbers in there, you want to go up, clear, down. Those numbers are gone. And then we just want to enter these numbers into our L1. Once we've entered those, we want to get our summary statistics. So to get to that, we do stat and then calc and one bar stats. You want to make sure you're calculating for L1 because that's where we put our data. And here's all our summary statistics. So these numbers are what we're going to use to fill in our blanks across here. So our mean is 27.875. Standard deviation, that's the SX, so let's start down here, is the 8.079. The minimum is 15. Q1 is 23.5. Median is 26.5. Q3 is 34. Max is 40. And how do I get the IQR? There you go. Q3 minus Q1. So I'm going to do 34 minus 23.5. That's, yeah. And then the range is going to be what? Max minus min. I heard somebody kind of whisper it. So 40 minus 15 would be 25. Okay, so are we all good with getting the summary statistics from a list in the data set? Okay. To do our box plot is just a visual representation of our 5-number summary. So we mark where is our minimum is at 15. Our Q1 is at 23.5, so it's going to be about right there. Our median is 26.5, so it's going to be about right there. Q3 is at 34. And then the maximum is at 40. There's a sketch of our box plot using the 5-number summary. Okay, so if I want to describe this distribution, what is the 4 things that I need to include when I'm describing? Thoughts. What's the S? Shape. What's the O? Odd features, outliers. What's the C? Center. How do I know which center to use? Yeah, we look at if it's skewed or not. If it's skewed, what do I use for center? Median. What do I use for spread if it's skewed? IQR. Okay. If it's symmetric, what do I use for center? Mean. If it's symmetric, what do I use for spread? Standard deviation. Okay. Make sure you remember those things. So on this one, what would we say is the shape? How can we use the numbers up here to tell? Which 2 values do we compare?
Median and mean.
Yeah. We can look at the median and the mean. If they are the same, what does that tell me? Symmetric. If they're not the same, it's skewed. So are these equal to each other? No. So that means it's skewed. The direction of skewness depends on which way the mean is from the median. So think of it on a number line. The median is kind of where we're starting, and then which way did I move to get to the mean? Right, so it's skewed right. Okay, make sense? If you're having trouble distinguishing, just compare mean and median. So here we're going to say the distribution of quiz scores. So there's our context. Is skewed right. And we said since it's skewed, I'm going to use what for center? Median. And I need to say that's what I'm using. With a median of 26.5. That's 26.5. I don't know what I did when I started to write that. We'll just mark it out and redo it. Who knows? 26.5. And what are we using for spread? It's skewed. So for spread, IQR. IQR is 10.5. So we've got everything in there we need. We didn't have any outliers, so we don't need to worry about this. Are we okay with describing that? Hopefully you guys are getting more confident with describing. I guarantee you will see one of these on your next test. I guarantee you you're going to see one on the AP. So you're going to see them a lot between now and then. Okay, so our next thing is if we add or subtract a constant. Think of what happens if you had something like, let me do this. So this is parent function for a quadratic. What happens if, what does that 3 do? Left. So anything added or subtracted in here is a left-right movement. Same thing here. When we're adding or subtracting a constant, it's going to be a left-right movement. Okay, it's going to do the same kind of thing that we saw in Algebra 2 with our parent functions there. So here what they're going to do is the teacher says, you know what, I have all these scores, and I got a median of 26.5. I have a mean of 27. This is out of 40. I'm not really happy with those. Maybe I want to do something to help these students out. So this teacher says, I think I'm going to add 10 points and make this out of 50, and everybody gets 10 points added, and we'll see how that works. So we want to know what are the new scores. Here's the thing. Your calculator does some amazing things. We can go back to the stat edit. Okay, now watch what I'm going to do and then do it on your calculator. Okay, eyes up here. See what I'm doing. So I went up to highlight the L2. Okay? Then what I'm going to do is say L1, see down at the bottom, down here it's showing you what I'm typing, L1 plus 10. Then when I hit enter, it fills it all in. So you're not having to type each one separate. Isn't that nice? On a list this short, it's not that big a deal, but if you have like 50 numbers, that's a time saver. Okay? So you can just go up to L2, type in second one for L1, plus 10, it will add those in for you. That's pretty nice. Okay? So these numbers are what you want to write in here. So just that list that's now in your L2 goes in these boxes across here. Once you have that to get your summary statistics, we're going to go stat, calc, 1-bar stats, and now we want to change that to L2. So if your calculator just puts the 1-bar stats into the home screen, just do second 2 to change it to L2, and then hit enter and it will calculate. So now these are the values I want to record as my summary statistics. Questions up to here? Are you okay with how I got those? Okay, so if I'm going to sketch a box plot, I'm using this 5-number summary to sketch what this box plot is going to look like. So my minimum was 25. My Q1 is 33.5. 34. So when I compare this box plot to the one that I drew up here, my original, hopefully you can see it's the same size, same shape, it just scooted to the right 10 places. So that adding 10 just moved it over 10. Okay? When you look at the summary statistics, some of them changed and some of them didn't. Which ones did not change? Range, IQR, standard deviation. What kind of measurements are those three things? What are they measuring? Spread. You notice how none of the measures of spread changed because this is still the same length as this one. It just moved over. It didn't change how spread out it is, it just shifted it. So on our summary, what we're going to summarize is measures of spread did not change. And then we'll call the others measure of location, so it's where they're located. So measures of location shifted right 10 because we added 10. Okay, questions up to this point? Are you doing okay? Alright, so this next option, this is our potential curve for these scores, is we're going to just double them all. So instead of making it out of 40, we're going to make it out of 80. So we're going to take each of these scores in our original data set and multiply by 2. So the way I'm going to do this on my calculator is I'm going to go back to Stat, Edit, and then L2, I'm just going to go up to the top of it and do 2 times L1. You see at the bottom, it's 2 times L1, so 2, second 1. And then it will replace all of those with the new values. So these numbers are what I'm going to record here. At 30, Q1 is at 47, median's at 53, Q3's at 68, and then my max is 80. No, we just median for the middle. So, hopefully you can see on this box plot, it's more spread out. We're seeing that difference in range shown here. Before it was a lot shorter, now it's longer. This is double the length of the other one because when we multiply by 2, it doubled the length. When you compare your summary statistics here with your original one, which values changed? All of them. So when multiplying or dividing, every value changes. All of your summary statistics change with multiplication or division. With addition and subtraction, it didn't affect the spread, but this does. Multiplying affects all summary statistics. So, multiplying or dividing changes location and spread. If you had one here, we multiply, but it could be they said divide by 2. It would do the same thing. Okay, so far we've tried 2 different things. We tried adding 10 points to make the test worth out of 50. We tried doubling, but then it's worth 80. So our third one says, okay, we're going to try doubling the scores and adding 20. That's going to make it out of 100 points. So we're going to go back to Stat, Edit, and then we're going to go up to L2, and I'm going to type in 2 times L1 plus 20. So 2L1 plus 20. And then it will fill in all of those for you. Okay. And these are the numbers that are going to be here. box plot. So hopefully here you're able to notice if we compare this box plot to the previous one, same amount of spread, just shifted over 20. So instead of the maximum being 80, it's 100. Instead of the minimum being 30, it's 50. So everything's just shifted over 20 from where this one was. So compare summary statistics between these last two data sets. So compare these summary statistics with these. Which are the same? Spread. Because, listen, when we do this, this is basically saying y equals 2x plus 20. That's basically what we're doing here. The multiplying affected spread, but the addition did not. Whether we are multiplying by just 2x or multiplying and adding 20, our spread numbers were the same. Okay? So, down here on our summary, we're going to say all measures were affected by the multiplication. But addition only affects location. This is on page 67. Yep. Okay, so here's how these problems typically look. Okay, so let's say I give you a set of summary statistics. Okay, so you have your mean, you have your standard deviation, you have your 5-number summary. This is supposed to be min. That says min. And I say I want you to transform these numbers using this formula. Okay? So what this is saying is we need to multiply by 3 and subtract 10. So you have to realize some of these you're going to just plug into this and do the whole thing. Some of them you do not. Some of them do not get affected by the subtraction. So if you are going to transform this set, you have to think about each one. Is it affected by multiplication, which everything is? Is it affected by addition, subtraction? Only measures of location, not spread. So for my new mean, I would say mean is location, so I just plug it in. So I would do 3 times 200 minus 10. So it would be 600 minus 10 would be 590. That's my new mean. When I go to standard deviation, that's a measure of spread. So this one, I just do 3 times 15.5, but I don't do the minus 10 because the negative 10 does not affect spread. So I only do the multiplication. Okay. Does that make sense to you? If I wanted to know my new median, median is just a measure of location, so I would just take that value, plug it in, and get the result. Up here, my IQR was 38. If I wanted to see what my new IQR is, I put this in, I do the 3 times the 38, but I don't do the minus 10 because minus and plus does not affect spread. So I just do the times 3. That's my new IQR. So you will have one like this on your problem set that you have today. You just have to think about, you just have to think about, am I doing a measure of spread? Thank you. Or location. If it's a measure of spread, don't do the plus or minus. Okay? It's not going to tell you that in the problem. You have to remember it. Okay? Makes sense? What are the 3 measures of spread that we typically use? IQR, range, standard deviation. Any of those 3, you don't do the plus or minus. You just do the multiplication or division. Okay. Hopefully that makes sense. Okay. So did you already put this on page 67? Once you get that on 67, we're going to work on this one with our z-scores. Okay, so, sorry, I'll let you guys see this video. Okay, so the first thing they ask us for on this z-score is, what is a z-score? Okay, so we need to come up with the definition. So a z-score is a measure of the number of standard deviations data value is away from the mean. That's what our standard deviation is, or our z-score is. It's saying how many standard deviations are we away from the mean. Okay, so I'm going to give you the formula two different ways, one with kind of words and one with just the symbols. So here we have a z-score equals the value minus the mean divided by standard deviation. So we're seeing how far away it is and then converting to units of standard deviation. Symbolically, this is the way we usually see it. We see z equals x, which is our value, minus the mean, which is x bar, over s, the standard deviation. So typically that's the way you will see it written, but this is just what that means. So if we do this calculation and we get a negative value, that means the number we subtracted was bigger than the number that we started with. So this subtraction yielded a negative. That means the mean is bigger than the mean. So the value is below the mean. So this tells us the value is below the mean. So what do we think happens if it's positive?
It's above the mean.
There you go. Value is above the mean. So the value minus the mean is smaller, so we end up with a positive number. Okay? What is the z-score of 0?
I'd imagine that means that they're the same.
You got it. Good deal. So we subtracted and we got 0. That means these two values were equal to each other. So the value is equal to the mean. So, in general, listen, the further from 0, so the absolute value of the z-score is what we're talking about. The further it is from 0, either positive or negative, then we say the more unusual the value. Typically, we'll say, remember how last time I was talking about if the probability is less than 5%, if you're at the 5% or above 95%, we're saying those are unusual. Here you're going to say an absolute value of the z-score that's more than 2 is going to be unusual. So it may be that they ask you to calculate a z-score and say, does this seem unusual to get this value? In general, if it's less than -2 or more than +2, it is an unusual value. Okay, so this bottom part is going to go back to your data that we did on Monday when we did our class numbers. So does anybody still, I don't know, you all should still have it. I didn't save it for all of my classes. So on page 65, you should have that data and that chart at the top. So somebody put that in their calculator for me and tell me what is our mean and our standard deviation. I don't save that information for every class. Get the mean and standard deviation yet? You get it? What'd you get? Perfect. Thank you. Okay, so write down those. This is our mean and our standard deviation. So for mine, my height is 66 inches. So mine would be below the mean. And to find out how many standard deviations, I'm just going to find the z-score. So I do my value minus the mean divided by standard deviation, and that's going to give me the z-score. Now typically z-scores are rounded to 2 decimal places. Would be negative 0.47. So you can calculate what yours would be. So you would just put your height right there and then calculate what would be your z-score. And it should be the farther your height is from 67.6, the larger the absolute value of your z-score. So z-scores are really helpful if we want to compare 2 different distributions to each other. So if we wanted to compare an ACT score with an SAT score, we could standardize your score on each one and compare to see which one did you do better on. Okay, which one did you have a higher z-score? So that allows us to compare the apples to oranges kind of thing. We can compare things from 2 different distributions to see how they did in relation to the other people in that distribution. So these are used really often. So it's an important thing. We're going to be using this throughout the rest of the year, doing z-scores and this type of calculation. So down here at the bottom it says, what would happen if we converted everyone's height to centimeters instead of inches? So how would that affect this calculation? So would your height also be different? It's going to change all 3 of the values, right? So will it change the z-score? Because all the values got multiplied by the same amount, the same multiplier, so it doesn't change. So changing units has no effect on the z-score. So, since z-scores do not have units themselves, they are a standardized unit, then changing your units of measure has no effect whatsoever. And that's something that they like to do on a multiple choice problem is they'll say, okay, here's this data, here's the z-score, but then we change the units. So how does that affect it? It doesn't. Okay? And they'll try to put things in there where it multiplies it by the same multiplier or whatever. And no, it doesn't affect it. Yes? Right, but see if we multiplied, we would multiply this, this, and this all by the same value. So then it would reduce down to the same number. Good question. Anyone else questions on that? Okay, so this is going to go on page 68. Then page 69 is where I left a page. I promised you guys I was going to leave a page every once in a while to just add some extra notes that you want to add. So that's going to be on page 69. Page 70 is where your problem set will go. This one, there's like several things that you're having to write out on it. And so I thought some people may need some extra room. So I left room on page 70 and 71 to write all of this out in case you need the space. So I'm going to give you guys a few minutes to work on that problem set. Let me know if you have questions. This is just dealing with the shifting data, like what we did on our first, the linear transformations, and then z-scores are also on there.